welcome. I'm Emily Bache, and if you haven't met me before, I've got a YouTube channel, I've written a couple of books, I'm on social media. Do feel free to send me an email if you'd like to get in touch. So I'd like to talk today about software development, and I'm sure you're all aware that developing software is complex, and we're all looking for better ways to do it. We're long past the days when one person could build everything, like those teenagers from the 1980s with their amazing demo software. These days we need teams of people working together for perhaps multiple years to produce something interesting. I think this research is one of the best sources we have of information about what really works in software development. And this is an overview from their website about what the research has come up with. They've got a lot of data about really, really effective organizations and what works. So this is the high-level picture. We want those outcomes, that organization performance, that well-being for employees. And they found that they can predict that you'll get those outcomes if you've got good performance. And they've found ways to measure that performance in terms of software delivery metrics and reliability metrics. And then the main body of the research, though, is what are the capabilities or the practices or the concrete things that you do in an organization that predict you'll get that performance, that predict you'll get those outcomes. And that is the really interesting part, I think. So this is the same diagram, just with the expanded, so you can see more of what's inside. And there's a bunch of capabilities you need in order for your software development to be successful. And that is, according to the research, they've looked at all sorts of factors, and these are some of the things that have come up. I wanted to highlight test automation. I'm a big fan of test automation as something that you need to help you with that fast feedback. You need code maintainability, so that you've got that, it's a big part of that climate for learning, that organization that is continually improving. And then I also wanted to highlight working in small batches as being really important for fast flow. And these are all the kinds of things that actually software developers are doing. And the decisions that software developers are making minute by minute are going to radically affect what happens in these kinds of areas. And there are also areas that I think there is far too little attention being paid to what software developers are doing in these areas. So I want to talk about team practices for code quality, for that maintainable code, for that ability to frequently release changes, and that code maintainability. And I'm putting test-driven development up on the slide straight away. This is a way of getting all of those things. It's not the only way, but it's a way that I think is very effective. And the inner loop TDD there is that's the tests there are driving the low-level design and the minute-by-minute coding decisions. And then the outer loop there of the acceptance tests are more kind of driving that we are building something useful to users that they would like to have. And that cycle goes around a bit more slowly. But this picture, I want to highlight refactoring in this as well, because refactoring is a big driver of good design and code maintainability. That's how you get it. But this is not the only testing we do. We have, for example, exploratory testing done by a very skilled manual tester. We have things like pair programming, continuous code review, where two people are coming up with a design collaboratively, or even more in an ensemble. We've got continuous integration. That's that fast feedback. How often can I share my work with my teammates and get additional feedback on whether it works? And domain-centric architecture, also known as like hexagonal architecture or clean architecture. These are approaches to large-scale decomposition that really emphasize encapsulation and separation of concerns. Also lead to high code quality. And right at the center there, though, is what I'm just calling clean and tidy code design. You know, writing classes with good names and methods that hang together, and that you haven't got 1,500 lines in every method and classes that you can hardly scroll through. So this is a picture I wanted to come back to in this presentation of what we want is those outcomes that the DORA research talks about. And I think all of these things are close to the code, close to the developers, and need to, in some way, be in place. So I'm interested, then, how much of this you're actually doing. So I've got a Mentimeter survey. that I'll just put the QR code back up. If you click on the QR code, hopefully you'll be able to get the survey and you'll be able to tell me about your organisation. Are you doing this stuff? Just so instead of just getting people to raise their hands, I'm doing surveys. Okay, most people I think have got their got the QR code. If you haven't got the QR code, there's a little number you can type in at the top of the screen. Great, it's working. So I'll just give everyone a chance to fill in the form. I'm going to have a few more questions later on, so I'm very grateful to you being a bit interactive. Cool. Cool, so a picture is emerging now. It does seem like pretty much everyone is doing continuous integration. We've got a lot of people using, a lot of people doing pair programming. Oh wow, that's unusual. I'm very pleased. This audience is I asked this question at another conference and that was much lower. So yeah, and clean and tidy code design is also getting a lot of attention here. A bit less on exploratory testing, maybe that's and a bit less on test-driven development, but still very strong showing for test-driven development. I'm impressed with this audience. When I ask this often, like everyone is like, well, we're doing continuous integration, but cool. So there's actually a very highly qualified group here, I think. So these are things that I think are important for code quality, code maintainability. And the reason perhaps we care about that is well, the DORA research says it's important, so it must be. But also just this relationship between how quickly and easily you can add new features. That there's this relationship. The higher the code quality, actually the faster you can change the code. And the lower the code quality, the longer it takes you. And that's anecdote. This is data. Now this is data that came out in a paper that was published a little while ago, Adam Thornhill and Marcus Borey. And they have a tool that has a proprietary code health metric, but it's basically a measure of code quality. And they were able to study a lot of different code bases and managed to correlate the time it took to resolve a JIRA issue in that code base with the quality of that piece of code. So they were able to find this very interesting relationship that's exactly that graph, only plotted in their way. So that if you compare the healthy code, the high quality code with the poor quality code, that it's taking 124% longer to resolve those JIRA issues. So that's a significant slowdown for feature development. But it's more than that. Also in this paper, they point out that it's not only that it's slower, this is the comparison of the maximum development time in those different code bases. And the high quality code compared with the lowest quality code, it could take 9 times longer. So it's not only that it's slower on average, but it's just totally unpredictable. Sometimes it takes 9 times longer than it should do, you know. So it's very difficult, if you've got poor quality code, it's very difficult to meet your schedules because things can just get blown out of all proportion. So I think this is actual data that backs up what a lot of people have been saying a while, that code quality really makes a difference. This is what Martin Fowler calls cruft, which is, I think, a very British term somehow. He describes it like this. This is deficiencies in internal quality that make it harder than it would ideally be to modify and extend that software. So there's the guy there with the lead weights he's dragging around. It's this cruft in the design is the problem. And it's kind of a similar idea to technical debt. But basically, he has an explanation of this, and I like his thought experiment here, where he says, okay, imagine you need to develop a new feature in your code base. And you could imagine that if the code was just perfect and had no cruft, it would take you 4 days. But then, unfortunately, the code has some design problems, and you reckon it's going to take you an additional 2 days to develop this feature because of the legacy of the code design decisions that were made there already. So that you can kind of do a bit of maths here and see, well, it's taken 33% longer than it would have without the cruft. So you can in some sense say, well, I was wasting a third of my time because there was cruft in the code. And in some ideal perfection, I could have not spent that time. So that's an explanation of the kind of the calculation that you could do to work out how much time are you wasting because of your internal design deficiencies in cruft. So let's go to the next slide here. So this is another survey I was going to... Can you just make an estimate how much of your code has got problems with technical debt or cruft? And how much time are you wasting as a percentage? So I'll give everyone a chance to think about this. Yeah? Picture is emerging here. Okay, so quite a lot of your code has got technical debt. It looks to be something around half. Not all. Some people have got a bit more, some people a bit less, but nobody's got zero, looks like. Okay, and then how much time are you wasting because of this? So again, mixed picture. So, some poor people. There's not very many up there, luckily. So there's a few here, but it looks like the majority of you, at least, is about 30%, a third. So similar to Martin Fowler's example, which is still, I mean, a third of your time. Now, I don't think you can get it to zero, so that wouldn't be realistic. But so this is actually very consistent with the results that proper researchers have got. So I've got a graphic here from a paper that came out a few years ago, suggesting that they did this properly. They asked the same question: what percentage of your time are you wasting scientifically? And you can see that a similar kind of spread, that some poor people, it's like they're getting nothing done. But most people are, this is a significant amount of time. And some lucky people are like, yeah, we got no problems here. And the average here is 23%. So not far from what the average of your scores were. But I'm not sure this is a normal distribution and that the average actually makes sense. So I think it's like everyone has got this problem. So what we'd really like, of course, is to control the technical debt, keep the code quality high, enable developers to be more effective. And this kind of thing is what you need to get that. And all of these practices don't come for free. So I want to talk about technical leadership, because that's, I think, what we need. To get this, we need technical leaders standing up and saying, we need this. Everyone should be doing this. And giving people support to get there. So in a typical large organization, you've got a bunch of teams with developers on them, and perhaps with some platform teams and enabling teams, I don't know, but teams. And you've got some kind of architectural leadership or technical leadership or staff engineers who kind of sit in between, who kind of set the overall technical direction. They are doing large-scale structural decomposition of the system. They're choosing technologies, and this is important work. There's a load of stuff that architects do that they absolutely need to do. But that's not what I'm talking about. What I normally see is that all this stuff about code quality, low-level design and engineering practices, TDD, refactoring, is totally not on their agenda. And then you go down into the individual teams and trying to find someone in the team who cares about this stuff. And you're like, occasionally you meet a team that has a tech lead, but so often there just isn't one. I mean, I can kind of understand in Agile everyone is equal in the team and we don't have roles because we need to pitch in and help one another. So I can kind of see that argument, but I'm just seeing it as a total abdication of nobody is really paying attention to getting the code quality up. And the quality of the code that I see in these big organizations. I mean, so this is my role here, the technical coach. And this is what I think is missing in a lot of cases, basically. Somebody who is part of the leadership, the technical leadership. It's not separate in any way from the architects, really. And it's got a similar mandate of actually being responsible across teams for these kind of technical practices. I don't think it lies in an individual team, but of course, all the decisions about these things happen in the teams with the developers coding. So as a technical coach, I join teams just temporarily and work with them. So I'm not full-time in any one team. I might be part-time in several at the same time. I'm supporting the tech lead, if there is one, or the wider technical leadership in the organization. So I'm not coming with my own agenda. I'm definitely there to reinforce and assist the rest of the stuff, because the architects are doing a bunch of important things and making decisions, and that's I've got to support that and their work as well. But also, I've got a big mandate to teach coding skills, because a lot of the reason that these things don't happen is to do with skill. We're going to talk about that more in a minute. So some is teaching, and some is just building this culture of ways of working, and what is the norms for an engineering team in my organization? What is the acceptable range of code designs that get through code review? I should mention code review. I mean, this does happen in most of the teams that I meet, but I see code review as really a forum for reinforcing things that people already know, and it's not really a great forum for teaching people to behave differently. That's where I think you really need some kind of more proactive coaching than just reviewing it afterwards. So this is kind of what I'm doing, and I'm going to talk first about the how, what I do. And I've got two kinds of activities that I do with the team, which are learning hours and ensemble. So a learning hour, this is, you can tell from the name, it's short. This is interactive, hands-on training for developers. This is in the context of a team. You're with your peers, and you're trying to learn coding skills. And I'm very inspired by Sharon Bowman. That's her books there about how to make training compelling in a professional setting. And she's got some really good techniques that I've really taken on board. So basically, we're trying to make training that developers want to come to, that teaches them things that they need to know for their normal work, that they can go back and apply soon. So a normal kind of one of these sessions would be, we take a piece of code, a training example that has some problems, and we'll discuss why it's got problems, what those problems are, put names on those things, increase the vocabulary for discussing what we mean by good quality code. Then we do some kind of coding demo of how we would clean this code up, and then everyone breaks into pairs and works on doing that on the same code as the example, and possibly a harder example as well, to kind of train this particular skill. So this is where I wanted to basically do a demo, and I've recorded it earlier, so it's a little bit less stressful. So let's see how this goes. So I've got some code on the screen here. This is the tennis refactoring kata, variant number 6. And this is a very nice little exercise because it's got really good tests. So if I just run those tests, you can see they're all passing and we're good. So if I scroll through the code, you can see this method getScore. It's kind of long. If I just scroll through it slowly, you can kind of see that it's doing some calculation, and it's got some conditional expressions, and I mean, in the scheme of things, this isn't very long, but we can't fit it on the screen, and we can't immediately really see what it's doing. So it's a method we could probably like to clean up a bit. And the IDE is pointing out, it's got a highlight there on line 29. I could fix this for you. So let's go and just fix that. These little things are pretty much free. And it's saying, oh, look, it could be a more beautiful Java switch expression. Great. So that improved the code a bit. And I formatted it as well. So we're getting somewhere with this. And the tests are obviously still passing. I didn't do anything complicated. But now, at this point, I'm going to go to my settings and turn off the AI assistant. And I don't know if you've ever discovered that you can turn the thing off if it's annoying you. But I'm not turning it off because I'm annoyed with it. It's because I'm doing an exercise. This code is open source. It's been on GitHub for 10 years or more, and it gives far too good suggestions. It does not do that on normal code. So my current solution for the AI tools solving my code katas like this is just to turn them off. because I want to train my other skills. I want to train the skills that are always going to be useful, like being able to name things and using the refactoring tools that come with this kind of IDE. So I've just turned that off. Now, of course, the test is still running. Now, this bit of code here is interesting because it starts with a little comment and it hangs together and it looks like a code paragraph. And this code paragraph, the solution is extract method. And the comment tells you what to name it. And in fact, the variable name tells you what to name it. Even the IDE can pick that up. Then I can inline that local variable. And I've got a nice little method. And now, of course, this condition, obviously, if that is get high score, then this must be is a tie, basically. So it's like, oh, that's a domino fell. I extracted that method with a name. That suggested the name of the next bit. That's good. This bit, oh, that's another code paragraph. Look, it also starts with a little comment, hangs together, works to extract. I can think of a good name using the comment or the variable name. I can inline that. And it's the same thing. I can then extract this condition. It must be, is this endgame? And then the last bit here is also a code paragraph. I just run my tests and check that the tools are working. I never expect actually an extract method to break the test, but I still like to have them. And then that was get regular score. So that one also can be inlined. And then this is starting to look really quite nice. So this is the conditional is basically decomposed. That's a refactoring called decompose conditional. But I've got a few. This result variable doesn't seem to be adding much, so I might just get rid of that and move the return closer to the computation. So that basically turned my rather long method that didn't fit on the screen into a really nice expression. If it's a tie, return the tie score. If it's endgame, return the endgame score. Otherwise, return the regular score. That's much more readable. That is a code quality increase in my book. So that was, and with the deterministic refactoring tools, it was very safe and easy to do. And so let's try the same thing on, there's another tennis variant in this refactoring exercise. I'm going to go to tennis game 3. Now, tennis game 3 also has a get score method with this kind of conditional. So let's decompose it. That first section there, get string. Yeah, get string. And let's decompose this second part as well. And get string 1. Yeah, I have no idea what it does, but I'm decomposing it. I'm refactoring. I'm improving it. Yes. OK, and this condition, well, it does something. It returns a Boolean. Yeah, it returns a Boolean. OK, so I think you can detect a slight hint of me not really believing in these refactorings here, because this is terrible. You don't want code to see code like that in your system. These names are entirely generic and meaningless for this problem, and I've decomposed the conditional, but is a Boolean return get string else return get string 1 tells me nothing. This is made the code objectively worse. So I think I'm trying to underline the point here that it's not enough just to kind of do the refactorings. You have to think about the names. Otherwise, it gets harder to read. So you can do this in such a way that the code gets worse too. And I had to turn off the AI tools because it gave really good suggestions for these names. So anyway, that was a demo of a technique. And now if we were doing this in a learning hour, I'd give you this code and send you off in pairs to go and do that. And if that was too easy, you can do it again with more shortcuts and more fluency. And if you're still too easy, I'll give you a harder one as well. So that's a little demo of a coding technique. So in that, I was using a bunch of keyboard shortcuts. I don't know if you saw them at the bottom of the screen. So I'm kind of interested, this group, how many of those keyboard shortcuts that I just used do you actually know and use fluently? Little quiz here. Yeah. Well, this is, I thought this must be a really qualified group from the TDD scores earlier. But yeah, a lot of people using a lot of shortcuts. I mean, like half of you are using things like extend selection, which when I go into teams in large organizations and try and watch them coding, they're using none of these. So this is you really know what you're doing here. And hide active tool window, perhaps you don't need that so often, but yeah, extract method, everyone knows. It seems lots of people know that. Reformatting the code, showing the context actions. Of course, the context actions can solve a lot of problems. Yeah, so anyway, usually when I go into teams, I find that they don't know these shortcuts. So just doing the exercise to learn the shortcuts helps, as well as then this discussion about what makes a good name and when should you do this. So anyway, this is the kind of thing that I find that is really useful. So back to the main presentation. So these are refactoring kata exercises. On my GitHub, I've got lots of these. These are a few of my favorites. Tennis that I just showed you, Gilded Rose, theatrical players. And you can train all kinds of refactoring skills with these. And I do suggest you turn off the Gen AI and just practice using the really reliable deterministic tools. I'm working on training Gen AI tools. I haven't quite got there yet. The other thing we train in these sessions is usually test-driven development. Exercises like FizzBuzz, Mars Rover, vending machine. There's a bunch of code kata descriptions on the Salman Coaching website. And these are, but I usually find that you need to train refactoring skills first before TDD really starts to get smooth. So, okay, so technical coaching. I think you've hopefully got the idea that one of the things I'm doing is these learning hours. The other part of it is the ensemble. So let me explain that. The ensemble is basically where we get the whole team together and we work on their code, the production code, the real code, not these exercises, you know, something where it's actually complex and important that we get it right. And we work on it all together as a team with the coach there as the kind of the mentor and the supporter, and also helping to direct us towards, you know, creating better code and learning to work in smaller steps and write better tests and all of that, actually in a realistic task. So this is really fun. I never know what a team's going to come up with, and then we start coding together, and we're like, oh, we could use this design pattern, and yeah. So this is such a great forum for a team to learn from one another anyway. And then if you add a more senior developer, like a technical coach, into that mix to mentor and encourage the right kinds of technical behaviors, this becomes a really fantastic forum for spreading those skills, the ways of talking about code, and get those new skills and ways of working that we were talking about in this toy practice code, getting that into the actual code. And there is, of course, a significant step in difficulty from the coding exercise, the refactoring thing, to the production code. And it really helps to have somebody senior there. I'm going to talk more about that. So this is the context I work with, a big organization, loads of different teams. I'm kind of working with this team and then that team and then the other team, and then maybe I'll go back to one of the other teams that I already met and take them to the next level. So gradually over time, everyone levels up. So that's the kind of the practicalities of it. I wanted to talk a little bit about the theory of what's going on here. This is Bloom's taxonomy. It's a very old idea from like the 1950s. It's basically used in teaching and designing learning, and teachers in schools use this. The idea is that there are 6 stages to learning about a thing, and you kind of progress from the bottom upwards. So first you have to remember what it is we're talking about before you can start to understand what's going on, and then you need to be able to apply what you've understood to different situations, and then analyze and in depth what's going on, and then evaluate which is the best idea, and then create new ideas. You know, it's kind of this is great, but I try to use this as a way to plan learning hours for teaching these kinds of skills, and I realized that it just wasn't really working. It turns out that Bloom's taxonomy is all about thinking skills. What can you think? What can you talk about? What can you write an essay for your English teacher or whoever? What we're doing when we're talking about software development, we're talking about practical skills. You have to be able to do it, and that's where actually you need a different way to describe the progression of how you learn a practical skill. And this is Hartman's proficiency taxonomy, which basically is a model that works a lot better for describing how software developers get practical coding skills. Of course, they're not completely disconnected. There is obviously you need a certain amount of thinking skills to attain the higher levels of the practical skills. But just to illustrate the difference, so the thinking skill is, if you were at the understand level of refactoring, you might be able to explain why refactoring matters. If you were at the second level of the other scale, the comprehension, then you can actually you can do it well enough. If you've given a checklist of what the steps are in the refactoring, you can do the refactoring. So and it kind of goes on from there. So it's what the difference between what you can say and what you can do, basically. So I think the Hartman's proficiency taxonomy is really interesting to understand. So I'm going to spend a few minutes now just going through it. So like the first step on the staircase of skill proficiency is familiarity. You know what the thing is. You know what it is, but you really wouldn't know how to start if you were trying to do it. So before this step, you didn't even know it was a thing. You'd never heard test-driven development. You had no idea that refactoring was a thing. So getting to this first step is, you come to a conference and you listen to talks about things and you get an idea that this thing exists and, oh, that would be exciting to know about. But that doesn't immediately mean you can go back and do it. So getting to familiar, you watch a demo or a conference talk. Comprehension, this is the next step. This is where you're good enough with the skill that if somebody's standing next to you, basically pointing and telling you what to do, you can do it. Or if you get a really detailed checklist that you can just work through, like a tutorial, you can do it. But as soon as you need to go off script or the person who is advising you disappears, you can't do it anymore. And that is, so getting from familiarity to comprehension, you need basically a checklist or a demo or some kind of support to be able to do it. And you can't deviate from that at all or you get lost. So that's the kind of thing you get in a demo or a training course where they give you this is how you do it. The next step then, conscious effort. This is where actually you can go off script a bit. You've learnt enough, you've understood enough about how the thing works that you can do some parts of the thing independently without help of a checklist or whatever, or without the help of a person pointing. But you can't do the whole thing yet. There are a significant number of situations where you just get stuck. You come to the end of what you can currently do and you're not done yet. So this is a little bit frustrating. Sometimes you might occasionally succeed by luck, but you don't have enough skill yet to really be successful. But to get from comprehension to conscious effort, you just need some simple problems to practice on. Ones where the checklist you've got isn't quite enough, but you can fill in the blanks. And so this is where code katas come in for a skill like refactoring. And you also need feedback on whether you're doing it right. If there's no source of feedback, the danger is that you do your little exercise and you think you've done it right, but actually you didn't. And then you're learning it wrong. So this is also why, like for a skill like refactoring, the code katas that I design all come with a really good suite of tests. And not that you'd have that in your production code, because you usually wouldn't. But if you're doing a refactoring exercise and the test fail, that's feedback. That's telling you did it wrong. You need to go back and do it again. So that's there needs to be some, either a teacher telling you or some source of feedback telling you, or a pair programming partner who'll say, actually, I don't think that's right here. So there needs to be not just that you're practicing on exercises, but feedback. Okay, conscious effort. Now this is where actually you can do all of it if you can concentrate. That's why it's called conscious action. You have to consciously think, okay, I'm going to do this thing, and you might need to make your own checklist, and then you might need to be really focused on following that thing and get to the result. But as soon as something comes in to put you off, like your boss shouts at you, or there's a stressful deadline, or there's a production bug, it just all falls apart. You can't do that at the same time as anything else. Your brain is completely full of this thing that you're doing. And that's so it's better than the previous one. You can succeed, but only if you've given peace and quiet. So you can take this step from conscious effort to conscious action by you need a variety of problems to face to make sure you can cover all the repertoire of situations you need to be able to handle. You need to be able to make this conscious plan of what you're going to do, and then validate that plan by following it, and get feedback on did it work. So similar to you need feedback at the conscious effort stage, you still need it here to make sure you're learning it right. Then we've got the next step, which is proficient. And this is when you've internalized enough of it that you can still do it even if these things are stressful. So this is what you actually need to be able to do this on the job, in your team, on real code. You need to be proficient. So the difference from that to conscious action is basically just you've got more fluency with the technique. More of it's in your long-term memory. Less of it needs to be top of mind all the time. So you make this step from conscious action to proficient basically through experience, repetition, doing it again and remembering what worked. You can also seek out situations for deliberate practice to deliberately, I'm going to train fluency in this, get it into my muscle memory. Mentoring helps, having people point out to you what you could do better and helping you to find a better path. So this is proficiency, self-evaluation and reflection. I think up until this point, you don't really know enough to be able to reflect on how good you are and what you still need to learn. Maybe at conscious action a bit as well, but here is where you maybe don't need that external source of feedback anymore. You can judge for yourself if it's going well. So this is where perhaps you need a mentor more than a teacher. And then, of course, there's a stage beyond that. You don't actually need to be anything more than proficient, but there are experts, people who are so good with a skill that they've got to unconscious competence. It's gone into their long-term memory to the point that they can't really explain what they're doing anymore. They're just like, well, obviously that's the design that we should go to. Like, well, how do you know that? Experience. So this is a kind of a Zen state that you get with experts. You get there through years and years of experience, and just things start to become natural. Challenging situations and reflecting with peers also helps. So that's why experts come to conferences, to meet their peers and try and understand what they're doing and move on the state of the art. So what often happens, though, is that for all these practical skills like refactoring and so on, we go to a training course or a conference, and we get the explanation of what it is, we get the demo, we get some exercises, and we're starting to get the hang of it. And then the training course ends after 3 or 5 days or whatever. And we go back to our desk, and we're like, I'm still at conscious effort. I can't actually do this thing. I can do it if I've got a checklist and it's not too different from the thing I did in the practice. And you're left to work out the rest by trial and error. And your production code is going to be much more complex than any exercises you did in the training. And trial and error is a hard way to learn. I mean, I know people who've done it, but it is a hard way to learn. And most people just give up. And I think this is one of the reasons the code quality is so poor in a lot of organizations, that there's a lack of skill, and there's the training that people have had has been inadequate. So that's, I think, why technical coaching works. The coach is proficient with these things that you're trying to teach. You know how to do domain-centric architecture. You've been doing it for years. You're proficient with refactoring. It's a natural way to work, and you know the tools. And so that's the technical coach then can go to a team. I've put them all at the same level of ability, but usually they're a mixture of levels when you get to them. And you can basically design learning hours to get them up the first few steps here. We'll do this exercise and that exercise, and you'll get the hang of this on a simple problem. And then somewhere about here, you need to move into the ensemble to make sure that they're applying this in real situations in the production code. And you're there to actually kind of remind them, this is the same technique that you were using in the exercise. Now we can get next level with it. And ultimately, you get them up to the same level that you're at over time. Because that's the other thing. The first 3 steps can go in a few days and a few learning hours, but this takes weeks and months and years, actually, to get really proficient often. So this is what the coach is doing. You're speeding up the skill acquisition journey and helping a whole team to get to the level where they're all proficient. Okay, so I've got another little survey for you. So who's doing this in your organization? I've just explained what a technical coach does. Is there anyone doing that in your organization, or who would you expect to do it? Cool. Cool. So I think most of the votes are in now. Oh, good. Oh, good. There is one technical coach in the room. Excellent. But mostly, and there are actually quite a lot of organizations that have tech leads, which is encouraging, because I think this kind of mentoring in the team is probably a really good place to put it. But just, this is a very popular choice here. And I just don't think this really works. Nobody takes responsibility for it. And code review happens, but that's not really the same. And there are some people being very honest about this and saying, actually, nobody's doing it. That's mostly what I see. Line managers, they don't have the skill. Architects, if they probably do have the skills, they have the coding skills, the technical skills, but are they, usually in my experience, they're busy with other stuff. So I think it can be a responsibility of architects. So this is interesting that technical coaching is not really taken off yet, I think is what I'm concluding here. So I've been doing this for quite a few years now, and my experience is largely in European companies, quite large ones, the kind of ones that have a lot of code that maybe is 10, 20 years old. I've also done quite a bit of pair coaching, where I pair up with another technical coach who's got different background and experience, and we bring the best of everything we have for that organization. It's a win-win situation, it really is. And I've also written a book about the way I do it, and what I've learned from other technical coaches. And I named it Samman because it's a Swedish word that means together. And I wanted to have something that you could Google that was my particular way of doing things. But as I said, different technical coaches have different ways of doing this, but I think the goal is the same. It's code quality, basically. I've also founded a society, a not-for-profit for technical coaches, where we can get together and discuss how things are going and what we've learned and how we can advance the state of the art. And we also provide resources. So if you go on our website, sammancoaching.org, those code kata descriptions I mentioned, and we've got learning hour descriptions with a walkthrough of, use this problem, do this demo, do this exercise, and what you can learn from that. So resources that could be useful for a technical coach. And also we have, every month we have an online meeting, just an hour, where you can meet other technical coaches and talk about your problems. It's an open space. So that's always very cool, to meet other technical coaches. And these are all free. You're very welcome to use them. Of course, there's a paid offering as well, but this is still very useful. So that, I'm going to skip over that. This is the big picture here. We're all interested in reducing code cruft, technical debt, because if we can get higher code quality, we can get faster feature development, and that DORA research tells us that we'll get better data metrics and we'll get better outcomes. And so this is, I think everyone wants to have good quality code. Test-driven development, I think, is a key enabler for that, along with those other technical practices I mentioned. And in particular, I think most organizations benefit from starting with refactoring as a direct way to raise code quality. And safe refactoring that you can do even when you have poor unit tests or not very many unit tests, or yeah, with good tools, you can refactor safely, and it's worth learning them. Then there's the Hartman proficiency taxonomy, which I think explains the skill acquisition journey that software developers go through. And if you are a technical coach, I think it certainly really helped me to be able to work out, okay, this team, who is at what stage of that proficiency taxonomy, and what intervention do they need now to get to the next stage? Is it practicing for fluency, or is it going through checklists to get to conscious effort? And then, yeah, if you would like to find out more, do come along and look at the Salman Coaching website. There, we'd love to see any aspiring technical coaches there, and as I said, it's a not-for-profit organisation. Thank you. I think we've got time for a few questions, if there are any. Yeah?
Do you think the tech lead taking on the coaching role works, or do you need a dedicated coach? Because I suppose the challenge I see is to bring something to the organisation, it's budget and it's convincing to make that happen.
The question was, can it work to get the tech lead doing this coaching? And that is something that I am actively looking into, because it makes a lot of sense. They're in the team, they know the team. But like you said, they need management support and resources to be able to devote a part of their time to technical coaching activities. And leading a learning hour, you can get some resources off the Salman Coaching website, but you do need a bit of prep time still. And getting that time away from feature development, there needs to be a discussion with your boss about that's a good use of your time. So I think I'm one of the things I'm trying to do is support tech leads with more resources for that. So yeah, I think it's a good way forward. And then hopefully you'd be able to be a player coach, and then maybe at some point in the future you'd graduate to full-time coach with other teams, maybe, or just, yeah. Good question. There's a question at the back, I think.
I was wondering if you've got any recommendations for these kind of techniques on teams with a significant difference in kind of experience and capability already, because you mentioned that was a thing you deal with, but I'm not sure how to implement some of these things without taking either starting too hard for the people who haven't seen it before or starting too easy for the people who have.
Yeah. No, that's it's actually a healthy sign if you've got a team with mixed experience and you're placing them at different points on that Hartman proficiency taxonomy. And like school teachers are like, a mixed ability class is really hard. And I can kind of get that. It is challenging because they've got different needs for what they need to learn next. But in the context of a team, you've got an interest in everyone in your team leveling up. So if you're one of those really experienced people who actually knows the skill quite well, I stick you in a pair with one of the least experienced people and make it clear to you that your role is to mentor them. You're not there, maybe you'll learn something yourself, but actually you already know it, so you're mentoring them. And that builds the team and builds that person's mentoring skills and helps that person to level up. So I usually find actually in some ways it's a strength to have a team with mixed experience if you can harness it to encourage the team to level up, and not just people to be selfish and think, well, I'm not learning anything. They've got to see this as an investment. And yeah, but it can be challenging as well to persuade them of that. Cool. So I'm not seeing any more questions, so thank you all for coming, and do come and talk to me afterwards.